Right, so these are the questions that may come up for translators. This video might be about 20 minutes long. I'll be display the question and then allow you to pause the video to have a go at you yourself. Then I will reveal the answers. Right then, so the first questions, as you can see, what is source code and what is object code? Right then, so the answers, so source code, a program written in a high-level language or in assembler by the user, easy for people to understand. It cannot run until it has been translated by the translator, so the compiler, interpreter and assembler, to object code. But then the next question is, what is object code? And it is a low-level language or machine code or binary code which is used by the computer and produced by the translator. So the source code, the main things that I remember from this is easy for people to understand, so it's human readable. It cannot be run until it has been translated by the translator. Normally that question's probably around 2 marks or so. Then object code, just a low-level language which is used by a computer and is produced by the translator. So what is executable code and what is intermediate code? So answer that question. Well then, so the answers for this are that there is the executable code is a complete program that the computer can run without further translation, which is now in machine code. Then the intermediate code that has been translated, usually by a compiler, into code that needs to be further translated, usually interpreted, before it can be run. Yeah, and that should be about 2 marks and maybe 1 mark, or just 2 marks probably actually. Yeah, just first one's probably 2 marks, second one's 2 marks as well, so they're both 2 marks. So now you can pause it and I'll reveal the answers. So the answers are that the linker, combines the modules or library routines that are already compiled, so they are in the object code. The loader copies modules into memory from backend store ready for execution, completes address links to the program. Various types of translators may be used when writing and preparing a new computer program. Explain the main purpose of a translator. And this is 2 marks, and this was from the June 2010 paper. Converts from source code to object code, detects errors in source code. So here we go. So explain the main purpose of a translator. Explain why intermediate code may be more useful than executable code. State why additional software is needed to run intermediate code. So the first question, so here are the answers, Ewan. So the main purpose of translator is converts from source code to object code and detects errors in the source code. An interpreter is more useful than executable code. Intermediate code is more useful than executable code due to it can run on various computers. Same intermediate code can be obtained from different high-level languages. Improves portability. State what additional software is needed to run the intermediate code. So it is 1 mark, so think back. What produces the intermediate code? An interpreter, or just say virtual machine, since a virtual machine uses the intermediate code to then produce the object code. The interpreter makes the object code. So now these are the questions. So state 1 disadvantage of using intermediate code. Software is used to convert source code into object code. Name this type of software. Explain the term source code. Explain the term source. That's right. Yeah. So now the. What was that? Right. So let me just do. There we go. Right then. So here are the answers. So state one disadvantage of using intermediate code. Now I think I did actually cover this. If not, I'm sorry. So here we go. Ooh, I didn't click on it. That's why. So the program runs more slowly, and or you could have said has to be translated each time it's run, or needs additional software. So I'll probably just say one disadvantage of using it is the first one, which is the program runs more slowly. And I might just do a little bit extra just in case I've messed something up anywhere. So software is used to convert source code into object code. Name the type of software. And that's from June 2011. So as you can see, it's actually quite a short answer. So what do you think it is? It is Translator. Now, explaining the term source code, that is different from what is source code, as the what is source code is what it exactly is, but then explaining the term source code is a bit more detailed. So the original code, or code written by the programmer, is often in a high-level language. It may be assembly language, because since it is a term of source code, the assembly language is, and then the source code can be understood by people, but cannot be executed until translated by the computer. So we go, and what would you do? Now, this thing, so two advantages of using intermediate code, and explain the meaning of the term virtual machine and how intermediate code is run on it. So this is kind of a bit repeating some questions before, but it didn't exactly need that far. Although it's good just to be well prepared. So here we go. Answer away. Well, so two advantages of using intermediate code are that intermediate code is a platform or independent, and maybe used on a variety of machines. Intermediate code program has to be compiled so it is error-free. Then explain the meaning of the term virtual machine and how intermediate code is run off it. So this is 2 marks, so here we go. A virtual machine is a generalized computer on which the program can run. Intermediate code is run using an interpreter for a specific computer as the interpreter, and you can compile it. The interpreter is it needs to be for a specific type of processor, the computer processor. So that'd be the times 32 and times 64-bit operating systems. With Windows, there's sometimes different installers for you to do. So I think the installers acting a bit like the interpreter, or compiler even. So let's go on to the next set of questions. Describe the two differences between machine code and assembly language. This is from the June 2011. So pause it now if you want to have a go at it. Here we go. Answers are being revealed. Machine code is written in binary or hexadecimal, whereas assembly language is written in plain text, includes mnemonics, includes names for data. Then machine code needs no translation, whereas assembly language is translated by an assembler. Machine code is very difficult to write, whereas assembly language is easier to write than machine code is very difficult to write, whereas assembly language is easier to write than machine code, but more difficult than a high-level language. Because some people could understand all of this, but it's easier to understand the high-level language since it's more human readable. Because machine code, that's in binary, and then assembly language, that is, I think it's is in binary as well, but it still has is a bit human readable, I think. So then, how well did you do? Did you get all the 4 marks? So next one, languages used in computers. So describe the term assembly language, describe the term machine code. Right, so here are the answers. So describe the term assembly language. A language related closely to the computer being programmed or low-level language or machine specific. Uses descriptive names for data stores, uses mnemonics for instructions, uses labels to allow selection. Each instruction is generally translated into one machine code instruction, may use macros. So this question is 2 marks, so I'll probably remember it. Language that is machine specific. It uses labels. Each instruction is generally translated into one machine code instruction and may use macros. So it's good if you try and get more than 2 points, because although this is only asking for 2 marks, you might have made a little bit of a mistake in like whatever. So say if you didn't specify a specific thing or so. So describe the term machine code. Binary notation, set of all instructions available for the architecture, which is dependent on the hardware design of the processor. Instructions operate on bytes of data. Right, so both of those questions are 2 marks, so let's go on to the next set of questions. Yay! Right, so this actually was used in my video of when I was doing about, what am I doing? This table shows statements about the types of computer language. In each row, tick the boxes to show for which type of language the statement is correct for. This was in the 3 L's and an A video, and this is at the end during assembly language. So, fill this in. So, now the answers, I'm just going to reveal them straight away. But what I can remember is that the machine that what uses mnemonics is let's see if I'm right. So, using mnemonics is assembly language, then uses binary or hexadecimal code is machine code, as it is in binary code. It is the low-level language. May use relative addressing, that is the high-level. Assembly language. May use local variables is the high-level language. Needs translation before the program can be executed, assembly language, and high-level language. Then may be translated into intermediate code is the high-level language. Right then, so the next set of questions. State 3 of the tasks performed by an assembler when producing machine code. Then either an interpreter or compiler may be used with a high-level language program. Describe one feature of an interpreter. So have a go at this, see how well you will do. So here are the answers. So 3 tasks performed by an assembler when producing machine code is that it translates a program from assembly language into machine code. So basically you just repeat the question there. One assembly language instruction is changed into one machine code instruction. Reserves storage for instructions and data. Replaces mnemonic opcodes by machine codes. Replaces symbolic addressing by numeric addressing. Creates symbol tables to match labels to addresses. Checks syntax / or offers diagnostic for errors. So describe one feature of an interpreter. Translates one line or statement at a time, then it allows it to be run before translating on translation of the next line. Reports one error at a time and stops. State two features of describe one feature of an interpreter, then state two features of a compiler. So, and then explain the term intermediate code and its use. So have a go at this. Now the answers for this are, for state two features of a compiler are the translates the whole program as a unit, creates an executable program or intermediate program, may report a number of errors at the same time, and optimization. Because there's the main stages of a compiler, which is the lexical analysis, the syntactical analysis, and then the code generation. So some compilers produce intermediate code, explain the term intermediate code and its use. Simplifies code or partially translated code, which can be run on any computer, virtual machine, improves portability using an interpreter. Sections of program can be written in different languages. I think that's meant to be a programming language, the max. Runs more slowly than executable code. So one stage of compilation is lexical analysis. Describe what happens during lexical analysis. The quality I'll just be saying the points, but if you try and do them in more of a complete sentence, but do not try and ramble on a bit, try and stick to these points. So have a go at this and see how I do. If not, just let the video play so we can see what the points actually are. So here we go. Source program is used as the input. So source code is used as input. Tokens are created from individual symbols and from the reserved words in the program. A token is a fixed length string of binary digits. Variable names are loaded into a lookup table or symbol table. Redundant characters such as spaces are removed. Comments are removed. Error diagnostics are given. Prepares code for syntax analysis. So how do you do this? You don't try and be specific with the points that you've made. They have to try and keep it in complete sentences. Otherwise, the examiner might just be try and be specific so they know what you are talking about. So you can probably do redundant characters such as spaces are removed, and comments are removed as well. So it's a marker. So you have to get at least, or try and get as many as you can, because you do kind of want to overdo it. So this question, see where it says prepares code for syntax analysis. Guess what the next question's on? Describe what happens during syntax analysis. So have a go at this if you want. Right then, so let's have a look at the answers. Accepts output from the lexical analysis. Statements or arithmetic expressions or tokens are checked against the rules of the language, or valid examples given. So match in brackets, that would be so you check to see, it'd just be like indenting and stuff like that. And a other example you could have given is every if has a match in end if. Errors are reported as a list at the end of compilation. Diagnostics may be given. If no errors, code is passed to code generation. Further detail is added to the symbol table, such as the data type or scope or address of the data, I believe. So the data type, the data scope, and the data address. So the next question is on So one stage of compilation is syntax analysis. Give the correct name for each of the other two stages. So we have seen them before, and it did mention them before. Well, it mentioned them before in the previous question. So see if you can have a go at this. So let's just have a look at the answers. So there's syntax analysis. There's the when compiler is used to produce executable code. Code generation includes optimization. Describe what optimization does. Well, have a go at this. Right then, so the answer, describe what optimization does. It makes code as efficient as possible. So it increases the processing speed, reduces the number of instructions, because you don't want loads of redundant like instructions to taking up the processor's time. Well then, so here's another table that you can do. So what happens during the compiler? So fill this table in and then we'll get the answers. So here we go, here are the answers. So the optimization occurs in the code generation. The logical errors are detected is not during compilation, because that is tested during that's a testing stage actually. I think that's black box testing maybe or so. Tokens are created in the lexical analysis, so spaces are removed and comments are removed as well. Incorrect punctuation is detected in the syntax analysis, as incorrect punctuation could just be is syntax because does it match the rules of the program. So how well did you do on that? Let's go on to the next question. Describe what is meant by a library routine and their use when producing programs. Describe how library routines are used when producing software. I think this might just be the same question, but have a go, see how well we can do. So let's have a look at the answers. So these do actually look very similar. So let's compare the answers. So use when describe what is meant by library routines when their use when producing programs, pieces of software. Routines often perform common tasks. Routines are compiled. Routines are error-free, available to programmer to use with a new program. But then for the describe how library routines are used when producing software, I think this is actually from one of the latest past papers. So I think I've seen this question before. So you do get may allow programmer to use code which was written in a different source language. Linker is used to link the routine to the program. Standard routines for sorting or searching are available. Allow programmer to use other expertise. Fit into modularization of algorithms, maybe used multiple times. The loader will handle addresses when loaded. So they are very similar, they're kind of similar questions, but they do have different answers basically. So the second one is a lot more information that you can get, but less marks. So let's go into the next set of questions. So this is a 8 marker. So explain why library routines help programmers and describe how library routines are used. So you can do it in points if you want, but it'd be better if you can do it in sentences and make it clear as to the points that you are making. So let's have a look at the answers. So explain why library routines help programmers and describe how library routines are used. Library routines are pieces of software which perform common tasks such as sorting or searching. Routines are compiled. Why library routines help programmers are the routines are error-free since they have already been tested. They are already available, ready to use, saves work or saves time, so I'll probably stick with the saves time thing. Routines may be used multiple times. Routines may have been written in a different source language, so that's similar to the previous thing. Allows programmers to use other expertise, so say if someone's that is linked pretty much with the previous answer. So routines may have been written in a different source language, allows programmer to use other expertise. How routines are used. Linker is used to link the routine with the program. Loader handles addresses when program is to be run. So how well did you do? Did you get all the marks? So basically, it's split into sections. So by library routines, then are pieces of software which performs common tasks such as sorting and searching. So if you should mention the library routines are pieces of software which perform common tasks. The library routines help the programmer by the routines being error-free, and it saves the programmer's time since it allows the programmer to use other expertise, since the routines may be written in different source languages. Then have the linker is used, and to mention loader, then to say why the linker and loader is used, and that should get you the 8 marks. So let's actually have a look at the next set of questions. I think there's more. No, that was the last one. So thanks for watching this video.